Hi, Dave Barden from Power Probe. So today we're going to do a little video showing you guys basically how to use these demonstration boards effectively and covering the differences between the tools, the 3, the 3S, and the Power Probe 4. And we'll show you the best way to demonstrate the ECT 3000 short and open finder on the white demonstration board. So we currently have two demo boards that you may see as dealers. This is our older version, we call the whiteboard. This one's very good for demonstrating the ECT 3000 short and open finder. Plus it's got a few points for demonstrating different voltages, different resistances, and you can activate a couple of components, light bulbs, motors, right from this board. You may only have this board, but there's quite a bit you can show on it. Our second board is what we call our blue board. Usually these are used in conjunction with the whiteboard. This one just has a couple of simple circuits on it. A simple lighting circuit and a relay controlled fan circuit running through similar fuse boxes and switches like you would see on a vehicle. And then it has a couple other test signals, one for fuel injection, one for pulse signals such as an ABS sensor, and one for resistance readings. These circuits also have what we call bug switches. So any one of these little bug switches, you're able to change the state of the circuit from a normal circuit to a high resistance circuit to an open circuit. So you're able to actually create circuit problems that then you can show how you diagnose quickly and accurately using one of the Power Probe tools. Now here we have the boards propped up. They can be laid down flat on the table just as easily. If you'd like to prop them up, we use simple electric guitar stands. They work very well. And you can run these boards off of, now you could pull an automotive battery. We use our jumper pack batteries wired directly to the boards. But you can use a typical automotive battery, motorcycle battery. It just has to have enough current to be able to trip the circuit breaker, so be able to pull about 20 amps. So we'll start with the blue board. Now on the blue board, we've fixed Velcro to the back of the tool so you can attach them to the display boards and they stand up. But they're easily removable. You can just peel them off, put them right back on. But you'll see on this board, we've got what represents the vehicle's battery up here, and got all the tools, the Power Probe 3, the 3S, and the 4, all connected to this one battery connection. So this battery, the positive, goes through a fuse box. We've got two fuses coming out. One goes to this relay, which will operate the fan circuit. One goes through this lamp for the lamp circuit. So two simple circuits, lamp circuit and relay powered fan circuit. Now these three test points over here, this one is for the fuel injector tester. This one is a 5-volt pulsed signal. Now you turn both of these on with this switch up here. And these are both running, if you hear that injector clicking. This bottom button changes the duty cycle of this 5-volt signal. It starts at a 10%. Every time you push it, it will go 20%, 30%. You'll see that on the pulse width screen of the frequency function of the tool. And the last piece here is for resistance readings, and you can flip the switch here for a couple of different readings. So let's talk about the different circuit testers we have on display here. Now Power Probe circuit testers combine the everyday needed functions technicians need when doing electrical circuit diagnosis. So even in the Power Probe 3, you've got the functions of a test light, checking power, checking ground. You have a voltmeter so you can read voltages. And we'll show you some other tricks it can do in just a second. But one thing you will notice, all the Power Probe tools connect directly on the vehicle's battery. Now you've got a nice 20-foot extension available, so you can get anywhere around the vehicle you need to. There are 20-foot extensions available if you need to get out to 40 feet for bigger buses, trucks, RVs. But you're always maintaining that permanent connection to the vehicle's battery. And that's important. It gives you a testing advantage over traditional tools. Number one, when I'm looking for voltage, you're normally going to get that red positive and that high tone with your voltage reading. But if it's always comparing, the Power Probe is always comparing the voltage on the tip to the voltage from the battery. If it sees a difference of more than half a volt, you won't get that light, you won't get that tone. Oh, see this spot here, we're down to 8.9 volts from our battery 12 volts. So no light, no tone. It's alerted us that there is some voltage drop in this circuit. Similarly, on the ground side, you should see green light, and if there's no more than half a volt on a ground circuit, you'll get that green light and get that tone. As soon as there's more than half a volt on the ground side, no light, no tone. I'm showing 2.8 volts on the ground side. That's not a good thing. Now the third advantage for all these tools being connected to the battery, kind of what they're famous for, is through this rocker switch, now I can apply battery power or battery ground directly out of the tip of the tool. So in a situation like this, where I'm testing ground and I don't have my green light, and I don't have my green light, I've got some voltage there. Well, by rolling this switch backwards, I can apply ground directly into the circuit and see how the circuit responds. Sure enough, my light got brighter. So it's a matter of figuring out where I lost my voltage. Now I can backtrack through the circuit. Now if I was a perfectly good ground here, but not here, I know something's wrong with my wire in between. We have a corroded wire, we have a loose connector, something like that. We'll repair that. Now my ground is reading correctly. Same with on the positive side. I have some voltage drop, I have no red light, I have no high tone. Again, now I can roll the switch forward and apply battery voltage directly to the circuit and see how it responds. That fixes my problem. My light is at full brightness now. So we'll back through the circuit. I'm still down voltage here. Oh, I've got correct battery voltage here, but I lost it here. So again, we've got something wrong with our wiring, corroded wire, loose connector. We'll repair that. Now your lighting circuit is back to normal. Good voltage coming in, good ground on the outside. But that's how that permanent battery connection, it's always comparing tip voltage to battery voltage, and it's always comparing ground to the battery ground. That's a unique testing advantage you don't get over traditional tools. Now the second tool here is our Power Probe 3S. This is an updated version of the Power Probe 3. These are functionally identical tools. We just gave it a bigger, easier to read display. We added a menu function to select the different test modes that are available in the PP3. A lot of people weren't aware these functions were in this tool. They are. It's just a matter of holding down the speaker button to get to the different functions. Here we made them really easy to select off a menu, and we did add one function. You can now flip the screen, so you can have the screen upside down or right side up, depending on how you're holding the tool while you're using it. Now speaking of those different test functions, here's your list. Top of the list is the voltmeter. That is the normal operating mode for the Power Probe 3 and the 3S. If I select that, you're going to see DC voltage. So anytime I probe, I'm going to get a volt reading. The same red light positive on power circuits and green light ground on ground circuits. And again, you can turn that speaker on or off. depending on whether you like or don't like that tone. Now let's discuss the different test modes. Now these are available in the 3 also, but easier to see here. First one on this list is what we call peak to peak mode. Now I'm going to select that. Now the Power Probe 3 and 3S is not a true AC meter. It never measures any negative pulses, but mostly in the automotive world we're only dealing with positive pulses, so this mode works very well in the automotive world. I'm going to turn on this signal generator. Now let me put it back in normal DC voltmeter mode real quick. Now this is a 5 volt pulse I'm tapping onto here. And the response here is a little erratic. I've got a very short pulse, so it's having a hard time picking it up. But it's trying to average it to about half the voltage, 2.4 volts. And most of your traditional meters will do that same thing. So we included this peak to peak mode. So in this mode selected, regardless of duty cycle, it's going to show me the true 5 volt pulse that that signal is putting out. Turn this on. That's peak to peak mode. The next mode down here is called max peak. Now this you would use while monitoring a circuit looking for spikes in voltage. You would connect it to the circuit, and from that point on it's going to show the highest voltage reading of that circuit. Let me connect to another spot and clear, and we'll try to get a lower reading. Okay, so at this point I'm only showing 8.8 volts, 11.9 volts. Even if I go back down to 8.8, it's still storing the highest reading. Another thing I like this mode for is if I'm probing in places I can't see, it kind of stores the reading for me. That's max peak. Next one down is min peak. Now this one's exactly the opposite. It's looking for any voltage dropouts or glitches that go lower from the battery voltage. Now here I'll connect to this battery. I'll reset my min and max peak. We'll cause some loads here. We'll see if we can get the voltage to drop. A little bit. But it's only going to store the lowest reading I see, even if the voltage goes back up. Now this last thing on the screen here is called AC threshold. Now this does 2 things. It's a setting. It's normally kept really high at 50 volts AC. You better never see 50 volt AC anywhere on an automotive system. So by keeping it high, it prevents the AC threshold and speaker activation from kicking in. If I want the AC threshold and speaker activation to work, I will select a different setting. Now there's a few different settings from 0.2 all the way up to 50. Generally you keep it high if you want the function disabled. Keep it low if you want the function enabled. I'm going to set it low, go back to my normal screen. Now it's going to do a couple of things. If it picks up a peak to peak reading, it automatically changed the tool to the peak to peak mode, and now the speaker is activated. You're able to actually hear the signal that's being put out. This mode for me is a fantastic mode to use for quick tests on things like wheel sensors, cam sensors, crank sensors. Just select that mode, connect to the sensor, spin the wheel. At least if a noise is being put out, you know that sensor is doing something. Now when it comes to applying power or ground from the rocker switch, you can supply whatever battery you're connected to, that's the voltage you're going to get. If you're on a 12 volt battery, you're going to get 12 volts out the tip. If you're on a 24 volt battery, you will get 24 volts out of the tip. Now you can power directly to a component on the vehicle, or there's an auxiliary ground lead off of each tool. So maybe you need to check a component in your hand. You can connect the ground lead on one side, power up on the other. So you're able to actively test components in your hand or on the vehicle. That's what we call true dynamic testing. You can ohm check a component all day long. It may tell you if you have an open or shorted windings, but it's not going to tell you things like if it's sticking or dragging or overheating during extended use, which you can tell by actually powering a component up. Now, the power probes all have a built-in 8 amp thermal circuit breaker. You can get away with powering 20-25 amps for a few seconds, but it's also perfectly safe. Even if you did a direct short, the worst thing you're going to do is trip the circuit breaker. Now it has the message on the screen, circuit breaker tripped, and you just push this reset tab on the side to reset the breaker and you're back in business. Now the Power Probe 4 is the most powerful of our power probes up here. It combines all the functions of the Power Probe 3, plus it's like packing a full functioning multimeter inside the tool. So besides your DC voltmeter modes, you've got modes for AC, resistance, frequency, pulse width. There's a couple of specialized tests like a driver test mode and a fuel injection test mode. All easily selectable from this test mode menu. So the Power Probe 4 is the most powerful, has the most electrical test built in. So first off, you'll see with the Power Probe 4, much larger display. I'm going to turn that speaker off. Much larger display, easy to read. You have things like min and max on the bottom of the display already. No need to pull up a separate mode. The red and green lights still operate the same way. Green for ground, red for positive, and operate by the same voltage drop rule. Okay, so let's get into that's the DC mode. That's pretty much the same as the Power Probe 3s. Let's go down to AC. Now we have two available AC modes, either AC RMS or AC peak to peak. AC RMS reads like a traditional voltmeter would, traditional AC voltmeter, and it kind of averages the signal. So in this case we have a 5 volt pulse. So you can see this one's averaging it, since it's half the time at 0 and half the time at 5, it's figuring it's half the voltage in between. Now if you're aware of that, that might be a useful reading, and this is how your traditional meters read. But in our Power Probe tools, we also include a peak-to-peak mode. So regardless of duty cycle, it's going to show me that is a 4.93 volt pulse. And your min and max display correctly. So if you're testing things like CAN networks, that bottom voltage and that top voltage will read correctly. So two AC modes, either RMS or peak-to-peak, depending on which one you need. Oh, let me turn this back on. We have a mode for frequency and pulse width all on one screen. There's my signal frequency. There's my positive and negative pulse widths, and we can change those so you can see that in action. So you've got your advanced frequency functions built into the Power Probe 4. So let's go to feed test. Feed test in the Power Probe 4 is your resistance meter. This is your ohm meter now. Now you would use the ground lead if you just want to check point-to-point resistance or continuity. Get a couple different readings here. Now that reads just like a standard ohm meter would, but what is kind of unique and why we call this feed test and not ohm meter is now I can actually tap into live circuits with voltage on it. If that speaker's on, you'll get that tone. But if it's a live circuit, you will either get the red or green light. Green light means that resistance number is from the battery negative to wherever you are in the circuit. Obviously, oh, I got a voltage drop. Red light is from the battery positive to wherever you are in the circuit. But you're actually able to take live readings, live resistance readings in active live circuits. We don't know of any other tool on the market that can do that. That can be a significant time saver. You don't have to depower the circuit to get a resistance reading. Our next is the fuel injector mode. Now, normally in real world testing, these are all 4mm banana jack connectors at the top. So you can add an extension lead, you can add back probes, any kind of circuit adapter you need. Typically fuel injector testing, you will use an extension lead with a back probe to get into the injector circuit. But for the demo here, let's just turn this on. Now, back probing into the injector circuit, the tool is going to respond like this. This is now your Noid light, telling you you're getting a good signal to the injector from the PCM. The speaker goes along with it. You can turn that off. Plus, you've got 4 pieces of data on the screen. I've got the injector on time in milliseconds. I have the ground from the computer driving the injector. I have the supply voltage through the windings of the injector. And this last one is called inductive kick voltage. It's that large inductive spike you will see on a scope pattern. That number varies from car to car, but typically you should see a very similar number cylinder to cylinder, like the compression test. If the windings in the injector begin to short out, that number will begin to drop off. You'll see a different number than the rest of the cylinders. But real quickly, one back probe in the injector circuit, you're able to see every aspect of that injector circuit. Just be aware that is not meant yet for diesel or gasoline direct injection vehicles. This is only for sequential fuel injection vehicles. A couple of less obvious things on the Power Probe 4 that are improved over the Power Probe 3s. The Power Probe 4 now is a sealed housing, so a lot more weather and watertight. All the tools still have the easily replaceable rocker switch that pops right out of the front and can be easily replaced if worn over time. The Power Probe 4 also has a replaceable circuit breaker under this back panel here. So long life, easily serviced parts if they do wear out. And speaking of the circuit breaker on the Power Probe 4, now if you trip the circuit breaker on the 4, it just resets itself after a couple of seconds. And this is a more advanced tool, and you will be testing more advanced circuits. So one of the concerns is being able to accidentally apply power or ground, possibly damaging something. So in the Power Probe 4, the DC meter mode is the only mode that you will be able to apply power or ground at the tip of the tool. We figure if you're testing resistance or frequency, you're probably on a more sensitive circuit, so we don't even want to let you accidentally apply power or ground. So you're locked out in every other mode except the DC meter mode. So you'll see the Power Probe 4 has a lot of improvements over the Power Probe 3s. All the different testing modes, the sealed housing, the automatic circuit breaker reset, the larger display with lots of information on each display, makes this the all-in-one testing solution. So this is the Power Probe Tek white demonstration board. And there's a lot of things you can show on this board, even with the traditional power probes. You can show checking voltage, checking ground, reading different voltages. Notice no red light, no tone. I have to be within half a volt of the battery I'm connected to. As soon as I drop down more than half a volt, no light, no tone. You're able to power up lamps with power or ground. You can spin a motor. You can demonstrate Checking continuity. Obviously, if there's an open circuit, there'll be no response. So a lot of things you can show on this whiteboard alone, but its greatest strength is for showing off our ECT 3000 short and open finder. The goal of this tool is to locate shorts or broken wires in the vehicle before you begin tearing the car apart. Tracking down shorts and broken wires can be a technician's worst nightmare. You can waste hours, sometimes days, chasing a wiring loom through the car, pulling seats and paneling and carpeting the whole way. The goal of this tool is hopefully we can locate where that short or break is before you begin tearing the vehicle apart. Pretty simple concept. It utilizes this transmitter, powered by the vehicle's battery again. This will put a signal into the circuit. You will basically track that signal with this receiver, and at some point you lose the signal is generally where your short or your broken wire is. So let's get this set up on this board and we'll show you how it actually runs. So on the white demonstration board, you'll notice there's 1, 2, 3 lighting legs, and they all come off a common circuit breaker, all coming from the battery. And we're going to cause a short on one of these circuits. We'll cause a short here by pressing this button. You heard it pops the circuit breaker, it's blowing the vehicle's fuse, it takes out all the lights. And lighting circuits can be one of the worst nightmares on vehicles because it's every corner of the car, the interior, are all covered by the same fuse. So where do you start? We want to locate where that short is on the vehicle without tearing everything apart. So real quickly, this is the transmitter. It has a 20-foot lead, and we'll connect to the vehicle's battery. We'll bring this around the back. Now the transmitter's powered up and it's putting a signal out here. You can use a variety of adapters. We have alligator clip adapters, back probe adapters, piercing adapters, whatever it takes to connect to the circuit. In the kit, you'll notice things like light bulb adapters. So a lot of people think you're stuck plugging into where the fuse is. You're not. You can plug in at the component side. You can tap in the middle of the circuit. The signal is going to go from where you start to where it hits the short or the break, regardless of where you start. So even if you're working on a big vehicle, maybe you're working from both directions, narrowing it down that way. For the demo here, I'm going to place you up top. It's down. And I'm going to pull this circuit breaker. And we'll plug directly onto the circuit side of the circuit breaker. Now that light and that tone, which you can turn off, is indicating yes, you do have a short somewhere on that circuit. Maybe you're in the vehicle moving things around, moving wire harness, you cause the short to go away, you would hear it change to that other tone. So now the signal's going into the circuit. And this is your receiver. You'll turn this on. And you'll notice it's picking up signals on all of these wires to a certain extent. And there's some similar tools on the market, and this is kind of where they come up short. Probably the most important step when using this tool is this sensitivity lock button here. So once you've got the transmitter injecting the signal, you've powered the receiver on, you find a spot where you got a good strong signal, and then lock yourself, set the working distance you want and lock yourself in. Now you won't get any false signals off the other wiring, it's only going to indicate off the wire that actually has the short. And notice that arrow, that's telling me the direction to the short, so no matter how I hold the tool, it's going to keep me on track. Now to really get the best results, you have to understand how this picks up the signal. The short signal is picked up by an antenna in this area of the tool. The open circuit signal is picked up by an antenna in this tip area. The open circuit signal is slightly weaker, so we realize you might have to dive into wire bundles to continue tracking. That's why this has that point on it. And so let's see, we're picking up the signal, and it's also directional. It reads off this bottom edge, and notice it indicates this way, but not when I hold it that way. So obviously you don't have nice lines to follow when you're tracking a vehicle wiring, but that kind of tells you the direction to go. If you're moving along, and you lose the signal, just check it didn't change direction on you. Oh, there, you picked it up again. Move along, and you've lost it again, and it's nowhere else around there. You can be pretty confident that's where your short or your broken wire is. Real quickly, in a matter of minutes, you're able to locate at least a lot closer where that broken wire or that shorted wire is on the vehicle, and you haven't taken anything apart yet. Now on the blue demo board, you'll notice these little toggle switches placed in different locations in the circuit. These are called bug switches. So if the circuit's normal, my light's bright, my fan's running like normal, everything's good, flip these switches in the down direction, everything's normal circuit. If you want to recreate high resistance, flip it to the top position. You notice the light got dimmer. I'll flip another one, we'll create some more resistance. So on the positive side, that'll create a voltage drop. On the negative side, that will create resistance that will show up as voltage. So you're able to create high resistance on either ground or positive side on the high position. So low, everything's normal. High, we have high resistance. There's a third position in the middle. That represents a broken wire. So any one of these you can put a broken wire on. You're able to use your Power Probe tool to track that fault.